All right, I'm going to do number 30 from chapter 13. This is the problem right here. An Earth satellite moves in a circular orbit at a speed of 5,500 meters per second. What is its orbital period? So here's the Earth, right here. And we know its velocity. So we have this going now, it's in a circular orbit. And we know it has a velocity equal to 5,500 meters per second. We want to know how long it takes to go around the Earth. So we need its period. Well, to get its period, there's two ways to do it. We can do this way. We know that the period is just equal to the distance it travels, 2 pi r, because it's going in a circle, divided by the velocity. But we don't know what r is. This is the distance r, right here. Okay? So if we don't know what r is, then we can't use this directly. Or we have another equation. We could use Kepler's third law, which says that t squared is equal to 4 pi squared over gm times it's a cubed, but in this case it's circular, so that just becomes r cubed. This is the mass of the Earth. Well, we know that, that's all a constant there, right? But again, we don't know r. So if we don't know r, we can't get t. So no matter what we do, we have to figure out what r is. Well, the easiest way to do this is say, oh, circular orbit. If you look back, I gave you that for an object in circular orbit, the velocity is equal to the square root of gm over r. Well, if we know that, let's just square that. So then the velocity squared is equal to gm over r, or r is equal to gm over v squared. So we can solve this for r. So we can say r is equal to g, which is 6.67 times 10 to the minus 11. Again, this is the mass of the Earth, which is 5.98 times 10 to the 24th. All divided by the velocity squared. Well, we have that, so we have 5,500 squared, and we get r. And in this case, we get r is equal to 1.318 times 10 to the 7th meters. Okay? Or yeah, once we get r now, hey, we can plug it into either one of these and solve for the period. So if you did the top one, it would be 2 pi times 1.318 times 10 to the 7th divided by the velocity, which is 5,500. To get the period, or you could do the bottom one and say t is equal to the square root of 4 pi squared over 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24th, the mass of the Earth. All that times the radius cubed, which is 1.318 times 10 to the 7th cubed. It's a 3 there. Either one of these will get you the same answer. This one's a lot easier to deal with. Now this only works in circular orbits. This works in elliptical orbits as long as you replace r with a in the semi-major absence. So this one's a more general equation. It can handle things much better than this one. This one works great for circular orbits. And when you do that, you get t is equal to 15,000 seconds, which is 4.18 hours. To orbit the Earth. And that's how you would do one like that.